Hello, welcome to Block 2, Solving Problems with Multiplication and Division. Lesson 2. I'll share my screen. So, in today's lesson, before we talk about today's lesson, in your previous lesson, you learned about the properties of multiplication and division. That was a very important lesson that laid the groundwork or the foundation for you to build a really good understanding and foundation in maths. In today's lesson, you're going to understand how to use factors and how to solve problems using factors of numbers. But before we start, I would like to appeal to you to help us grow our mission to educate the global population of children who may not be able to afford high quality maths education or afford a private teacher. To help us do that, like the video, share it with those who can benefit from it, subscribe to the channel, click on the notification bell so that when new videos are produced, you will be notified. Thank you. Before we start, I would like you to answer these retrieval practice questions in 3 minutes. You can take a shorter time. Okay, assuming you've answered the questions, here are the answers. Let's discuss them. So for the first one, you were asked what multiplication facts are being shown by the array. The array shows 7 by 3. So we can see that we have 7 columns and then 3 rows. So 7 times 3 is 21. And it also shows 3 rows and 7 columns. Here you ask what division facts are shown by the array. Here we can see that we have 6 columns and 2 rows. Now, this can be interpreted as that, okay, if we were to share 12 counters amongst 2 people, each of them will get 6 counters. It also shows that, okay, if we were to share 12 counters among 6 people, each of them will get 2 counters. Next, you ask, write down as many times tables as you can with an answer of 5. Of course, we can only show 2, which is 1 times 5 or 5 times 1. Let's do some new learning. Before we start, it's important we understand what the term factor means. Factor can be regarded as a whole number that can divide exactly into another number. We can also interpret factor as 2 whole numbers that we can multiply to get another number that we call product. So in this case, we can say 3 and 4 are factors of 12 because we can multiply 3 and 4 to get 12. So I want you to take note of these 2 definitions, but I want you to take note especially of the last one that I mentioned. We can use a bar model to understand what factors really are. Here, this bar model is showing us that, well, if we were to divide 12 items, could be anything, could be, 12 counters, it could be 12 bars of chocolate, amongst 3 people, each of them will get 4 bars of chocolate. So if we were to divide 12 bars of chocolate amongst 3 people, that's why we have 3. Okay, the bar is split equally into 3 parts. Each of them will have 4 bars of chocolate. This one shows that if we were to split 12 bars of chocolate amongst 4 people, let's say you have a friend popped by and say, "Oh, can I have some, please?" All right, now you're going to have less. You got to be generous, don't you? So each of them will have 3 chocolate each because they're now 4 people. Now, we can also think about factors using arrays. Arrays is just a way, think about it, visualize it as rearranging counters in an orderly fashion where you have different rows and columns. Now, remember what I said, that we can understand factors as 2 pairs of integers that we can multiply to get another number called the product. So in this case, the product of 3 and 4 is 12. I'll repeat, the product of 3 and 4 is 12. So it's important you understand these words because you're going to see them in maths and you're going to hear people talk about, say things like that. So you know exactly what they mean. So here we have this array. Okay. We can say it's a 3 by 4 array. All right. Let's use the idea to find factors of 12. Now we're going to start with 1. Okay. 1. Now, if we were to arrange 12 counters, we can start by saying, well, we can have 1 and 12. What does that mean? It means we arrange all the counters in one column, but we have 12 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can also have a different array. So we can say, well, this is a 2 by 6 array. So we have 2 columns and we have 6 rows. Of course, the factors of 12 are now 2 and 6 because we can multiply 2 and 6 to get 12. We can also have 3 by 4. We can also have 5. Really? Do you think that would work? Well, let's check. Well, I was wrong. Okay, deliberately wrong. So we can see that we could not complete a sensible array like we did for the others. So 5 is not a factor. Well, what you've learned so far is you have learned what the meaning of factor is. You have learned how to find factors of numbers by visualizing those numbers as arrays. It's now time for you to practice. Pause the video and answer question 1 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So these are all the factors of 24. And then here is asked to use counters to explain why 5 is not a factor of 24. Well, if we tried to arrange our arrays using 5, so where we have 5 columns like we did here, okay, you would see that we won't have a complete array which would contain all the 24 counters. Pause the video and answer questions 2 and 3 in 3 minutes. All right, assuming you've paused the video and you've answered questions 2 and 3, here are the answers. So question 2, you were asked, draw all of the arrays that you can make using 16 counters. We can do lots of them. So by doing the arrays, it's another way of finding the factors of 16. And here they are. And then next, draw all of the arrays that you can make using 7 counters. It's just one. And what do you notice? 7 has just 2 factors, 1 and 7. What does your answer, let's see, just a minute. What does your answer to part A tell you about the number 7? Well, it tells us that the number 7 is a special number. In fact, I want to tell you the name we give such special numbers that only have 2 factors. Drum roll, drum roll, drum roll, drum roll is called prime number. So 7 is a prime number. All right, pause the video and answer questions 4 and 5 in 3 minutes. Assuming you've paused the video and you've answered questions 4 and 5, here are the answers. Let's discuss them. So here you were asked to complete the factor pairs for 20. So here are the factor pairs. So now we're beginning to think about factor pairs of numbers. So factor pairs are the two numbers that we can multiply to get that number. Okay. So when we're thinking of factor pairs, we're thinking of numbers that we could multiply to get 20. And then find all of the factors of these numbers. Okay. 25, 18, and 30. So here are the answers. Now, take note of the way we list the factors. We're just not listing them anyhow. We're listing them in order of size, okay? Starting from the smallest. All right, let's do some new learning. Here, this young man says the first factor pair of 100 is 1 and 100. Yes, he's right. We've seen that in our other examples that the first factor pairs were always found was 1 and the number itself. Now, he says, I can find the rest of the factor pairs by doubling one number and halving the other. Well, is he actually right? Let's investigate it. So if we do what he said, okay, let's call him Ame, or let's call him Peter, it's going to be 1 and 100. So if we double 1, it's going to be 2. And then if we have 100, it's going to be 50. Okay, interesting. Now let's do it again. 4 and we have 50, that will be 25. But if we double 4, we're going to get 8. All right. But if we have 25, we won't, it's going to be 12.5. So remember, we want integers. Integers mean whole numbers. So that is not going to work. So we're going to disagree with him. So what he has missed by using his method, he has missed the factors 5 and 20. And of course, he's also missed another factor of 10, which is 10. Now, we're not going to list 10 twice when we list the factors because we just list one number. That is, when we list the factors, we just list the factors. But if you're asked to list factor pairs, you're going to list 10 times 10 because we can form an array of 10 by 10. So 10 columns by 10 rows will give us 100. Okay, let's do some further learning. Sometimes you'll be asked to find the common factors of two numbers. So you'll be given two numbers. You already now know how to find the factors of numbers. So you find the factors and then they'll say, okay, find the factor of another number, but this time we want you to find the common factor. So common means the factor that you can find in 12 and also in 30. So watch this. So the factors of 12 are these. And the factors of 30 are these. Now, common means the number, the factor that is common to both 12 and 30. Now, if we do that, we can see that these numbers are common to both factors of 12 and 30. Now, we can list them. We can say, well, we write a simple statement. The common factors of 12 and 30 are 1, 2, 3, and 6. Okay, then. Sometimes we can take it a bit further and say, well, now that we know the common factors of these two numbers, what is the highest common factor? So what is the highest of these numbers that are listed here? And that takes it a bit further. We'll say, well, we'll list it out and then we can see that the highest number there is 6. So we'll write a simple sentence. We'll say 6 is the highest common factor of 12 and 30. Okay, it's now time for you to practice. But before we practice, what have you learned so far? You have learned that you can find the common factors of numbers by listing the factors of the numbers and then picking out the factors that are common to both numbers. You can also find the highest common factor by listing the common factors of both numbers and then pick the highest number. It's now time for you to practice. So pause the video and answer questions 6 and 7 in 3 minutes. All right. Assuming you've paused the video and answered the questions, here are the answers. Here you were asked 4.5 times 2 is equal to 9. So 4.5 must be a factor of 9. Is Annie correct? No. And what's the reasoning? We are interested in integers. Integers mean whole numbers. Next, we're asked, Philip is finding the factors of 60. He finds the following factors by halving and doubling the numbers in the previous factor pair. And here are they. Here are they. Now, Philip thinks he has found all of the factors of 60 because he can't have 15. Well, that's not true. All right? That's not true. So he's wrong. So explain why. Because there are other factors he has missed. So if there are factors that exist that we can multiply to get 60, he's definitely wrong. We can see that 15 times 4 is 60. All right. Pause the video and answer question 8 in 3 minutes. Now, there is something you need to pay attention to, which is this word here, Venn diagram. You're going to see it sometime in the future. Okay. All right. Assuming you've paused the video and you've answered the questions, here are the answers. So here you were asked to complete the Venn diagram, write the factors of 32, write that, and then here, what are the common factors shown in the Venn diagram? So you were required to complete them. Okay. So here are the common factors. So the common factors are the factors you can see where the two circles of the circle for 32 and the circle for 24 overlap. All right. And then here you're asked to fill the numbers in. Okay. 32. There's 12. These are all factor pairs. Okay. These are all factors of 32. And these are all factors of 24. What is the highest common factor of shown in the Venn diagram? The highest common factor is 8. Okay. Find the common factors, question 9. Pause the video and answer question 9 in 3 minutes. Assuming you've paused the video and you've answered question 9, here are the answers. Let's discuss them. So here you were asked to find the common factors of these pairs of numbers. By now you know how to do them. So here are the answers. You can mark your work now. All right, that brings us to the end of our lesson. So in this lesson, what have you learned? You have learned what factors are. You have learned how to think about factors as pairs of integers that you can multiply to get a particular number. You also made progress to learn that if you now know how to find factors of numbers, you can find common factors of more than one number. So if you're given two numbers, you can find the common factors of those numbers, and then you can, after you found the common factors, you can find the highest common factor of those pairs of numbers by listing the common factors and picking out the highest number of those list of common factors. You also made progress to know how to fill in using the information you get about common factors and highest common factors, how to fill a Venn diagram. A really important concept that you will learn a lot more of as you study and grow in your knowledge of maths. Thank you for sticking around and for learning. Until next time, take really good care of yourself. Bye-bye.